Hi, everyone, and welcome to the live Q&A session. My name is Ernesto Gonzalez, and I'm engineering manager at Meta, and I'm going to be moderating the conversation today. First, thanks to all the speakers for the presentations. In the panel, we have a speaker for the morning session, for today's session, Lu Pan from Meta, Jun Rao for Confluent, Ali Zaveri from Meta, and Suyog Mapara from Meta. And with that, we're going to start the questions. First, for Lu. Couldn't the caching bug you described be discovered using unit testing?
Yeah, thanks for the question. That's a great question. And so in theory, in this case, unit test works when you know exactly the scenario you're testing against. For example, in this case, that in test you can have make operations internally, inject transient errors when we process in the caching validations, etc. We actually added exactly that kind of test right after we identified the bug. The challenge in practice is that there are complex scenarios that can potentially lead to cache inconsistencies. We just don't know ahead of time which ones that can happen so that we can write the test for. So it's almost impractical to have a unit test for all of them. So at least I'm not aware of how. That being said, I guess something similar to, Netflix has this pretty famous testing framework like a Chaos Monkey, but it's used mostly for stateless services. But, you can imagine something like a Chaos Monkey for stateful services that kind of just inject random failures in places that can potentially fail. And then the next challenge will be like once there's a unit test of failure in that kind of setup, how do you actually debug that? FoundationDB has this very famous test framework that kind of makes every test of failure repeatable in a distributed system. So in combination of these two, I think there's a possibility to actually kind of help detect the flaws earlier. And then complement what we covered in the talk, which is more about production system monitorings and observabilities and debugability. I hope that answers the question. Thanks.
Yeah, so basically it's very difficult to test for what you haven't not predicted yet. But it seems that your team is actually adding, or you guys are adding testing after you find these issues. Right, so the second question for you as well, Lou. How Polaris capture inconsistencies do we do failovers?
Yeah, that's a great question too. So the short answer is that Polaris has no idea of failover to begin with. So because just as clients don't know when failover is happening behind the scenes in a complicated distributed systems, like Lamport has this famous definition of a distributed systems is that a machine that you don't know even exists will render your system unusable, right? Because like all those massive implementation details behind the scenes are kind of abstracted away from the client. And one key design philosophy that we took about Polaris is that it will only act as a client and the focus is only on client observable anomalies or invariants. So in this case, it means that it doesn't care about what causes the inconsistencies, but only focuses on if the cache is in an inconsistent state. So because it's a much easier problem to solve and a much scalable way to solve it. Then it's the consistency tracing library's job, which we covered in the second half of the talk. It's its job to answer the question of why and how cache got into that inconsistent state, because it's a library that's embedded into every single cache service we have at Meta, and then it will trace all the state changes, and then it can tell us in this case that, for example, the inconsistency was caused by failovers. I hope that answers the question. Thanks. It's a good question.
Thank you, Lou. June, would you consider data managed by streaming databases as data in motion?
Yeah, sorry, Ernest, could you just answer that question again? I didn't get it clearly.
Yeah, no problem. Would you consider data managed by streaming databases as data in motion?
Yeah, well, I think in general, I think it's the difference, right? I think between like data in motion and data rest is, I think the focus is a little bit different. In both cases, you sort of manage data, but data at rest mostly focusing on storing the data. That's the sort of primary way of dealing with data, right? But how do you act on that data typically happens later. But what data in motion system focuses on is to flip that around. Is in addition to storing that data, it focuses on acting on that data. So as soon as something happens right in the world, you can actually take action on that in real time instead of having to do that in batches. So that's like a big trend we are seeing in the world. Just as a lot of businesses are moving towards more real time, they want to be able to proactively act on changes, right? What's happening, what's interesting that's happening in the world, and then do something as those events are happening. And that's proven to be used for when we have just unpredictable environments like pandemic, right? I think, but in general, a lot of places just realize, I think the more they can act on those event changes, I think the more prepared their business would be. So that's sort of, I would say, the key difference of this daily motion system.
Right. I have a follow-up question for you, Yoon. Actually, it's a different question. How you see cons and pros for self-managed Kafka versus cloud-managed Kafka? I think in particular, they are talking about AWS MSK versus cloud-native data streaming services like AWS Kinesis.
Yeah, that's a good question. Thanks. I think the first thing I would say is for a lot of infrastructure, data in motion, Kafka included, we think over time, I think offering that as a hosted service is actually a better way of delivering the software. We started as a on-prem business, right, Confluent, but over time we just realized, I think managing like a distributed system like Kafka is actually not easy. Maybe it's okay for a lot of tech companies, but for a lot of like mainstream users, right, I think that's not their core competence. You'd rather let someone who is focused on this to manage the operation part of the system, and then so that those businesses can focus on their core applications. So that's the first thing. So offering that as a hosted service, I think makes the adoption of this newer technology a lot easier. The second thing is, okay, in terms of what kind of service you can build right in the cloud, that we believe if you have a service that's more cloud native, right? If you design your system that can architect to take advantage of the relevant part of various cloud resources, then you can overall build a much more compelling service that's either more elastic, more cost effective, or more performing. So that's what we have been doing at Confluent Cloud. We're taking open source software, but make that more cloud native so that it can use the cloud resources more judiciously. Lastly, I think if you compare with Confluent Cloud, right, to services like Kinesis. If like Kinesis, technology, I think it's is not necessarily is also pretty solid, but it's only available in one cloud. So I think what we have been seeing is in today's world, right? I think this kind of portability of a software stack in different environments is super important for our users, because when people are moving to the cloud, right, this is actually a multi-year journey, right? So in this journey, they will have potentially some on-prem presence, right? They will have some cloud presence, and then for various reasons, whether it's acquisition or other things, people want to also consider multiple cloud. So in this environment, having the same software stack but be able to deploy it in any environment the business need to run is super important. So from that perspective, you have a service, right, that can be offered in all those environments, whether it's on-prem or all those different cloud, is super appealing to a lot of businesses.
All right, thank you, Yoon. Ali and Suyog, the next question is for you. Are there plans to open source Zelos?
Yeah, thanks for the question. We don't have any immediate plans to open source Zelos, but actually as a first step, we are thinking of open sourcing the Delos platform itself. I think that is the most beneficial in our minds, because it'll allow users of the platform to build their own storage API offerings. So we are planning for this, but we don't have any concrete timelines as yet.
Okay, thanks. So is there any, so there is no timeline at all? We don't know if at any point we're going to be opening it, or?
We're still planning for the platform. I think you'll hear shortly from us.
So stay tuned for that.
Sorry?
Stay tuned for an announcement in the coming month.
Yeah.
All right, cool, thanks. Luke, back to you. Your talk assumes an invalidation-based cache consistency model. A TTL-based cache doesn't have the invalidations and seems much simpler. How you compare the two, and what are the pros and cons?
Yeah, thanks. That's a great question. And then it's absolutely right that TTL-based cache has a much simpler consistency model than the invalidation. And if we learn anything, is that cache invalidation is a hard problem. And then we tried very hard to make it more manageable. And then we think it's become much easier now. But so one thing that's when we're comparing an invalidation-based consistency model versus a TTL-based consistency model, workload matters a lot. For example, like on the social graph, that's a user profile. So it's a data stored in the social graph, it's cached in tau. And then those type of data, they don't change a lot. Like usually, I mean, people don't change their names all the time. So, and then they're very infrequently updated. And then if we impose an TTL on it, then for example, we invalidate it after 2 seconds, then that means like those, and also the data is frequently read, right? Every time you go to Facebook or Instagram, you load your user profile, like that's the first thing you have to do. So that means well, basically you're going to have a higher hit rate, and you're going to send more queries to the upstream, like the databases, and then also have a higher latency to load the page and all those potentially downsides. And then so for those type of workloads, like invalidation based, will actually is net positive. And then but for there's also the other extreme end of the spectrum is that, you know, some data is just super frequently updated, that like can be tens of thousands of mutations on the same item in a second. And then for those type of workloads and infrequently read, let's say, then that will be like a very invalidation unfriendly and then TTL friendly. So it's a kind of workload based. And then if that answers the question, thanks.
All right, cool. June, if you were to redo the execution of this project, knowing what you know now, after several years working on the space, what would you have done differently?
Well, yeah, I think I probably would think a little bit more on the cloud. So when we started with Kafka, right, I think cloud was still in its infancy. So we sort of built it, just mostly for on-prem use cases. But as I mentioned earlier in the previous question, is I think we think, just given the current trend, offering those infrastructure software like Kafka, right, as a service is just a better way of delivering the software. So if I'm starting like the same project again, right, I probably would think of, how we can design the system so that it can be more cloud native from ground up. I think over time at the company, we have re-architected Kafka to be more cloud native. But if you have a luxury to start again, I think thinking about how you would design architecture in the cloud, especially in this multi-cloud environment, right, would probably help you build like a overall architecture, the right architecture, even from the very beginning. Because the cloud environment is it sort of forces you to think about resource a little bit differently, instead of just buying and paying the hardware like once, right, and so you can use it forever afterward. In the cloud, you mostly pay for what you use, right? So being more judiciously about what kind of resources you can use, and think about how that fits with the cost model in each of the cloud vendors. I think that's super important.
All right, so basically you're seeing this going in the direction of serverless architecture, or this is just another serverless service?
Yeah, I think basically you want to take advantage all the benefits, right, you get out of the cloud, right? So one is, of course, you will be taking over the operation. The users don't have to figure out the details of which hardware or how many servers it runs, right? That's the first step. But the next step would be, okay, what are some of the architecture decisions you can make to make it more elastic, to make it more cost effective, right, and more scalable.
All right, cool. I have another question for you, Jim. How do you see services that deal with huge sets of data evolving beyond moving to an event-driven architecture? You kind of mentioned a little bit about the serverless space, but where do you see this space going in the future?
Yeah, thanks. Yeah, that's a good question. I think the industry, I think in general, seems to be moving towards away from monolithic systems. This is happening in the infrastructure space. It's no longer the case where all the companies are running a single gigantic database. Instead, people are adopting hundreds or maybe tens of those different specialized systems, right, within their company. Those systems can be, maybe they can do data warehouse a lot better. Maybe they can do certain type of analytic, like time series data better. Maybe they can do like a graph processing a lot better, right? So this is a trend. And then if you look at a lot of cloud vendors like AWS, they are not just offering a single service, right? They are offering hundreds of those specialized services that's good for processing the data in various ways. So that's the trend we are seeing in the infrastructure space. And in the application space, we are seeing the same thing, which is there's no longer a case where the business will just build everything they have, right, in a single monolithic application, because that's hard to evolve, right? That's hard to change. Instead, I think a lot of companies are breaking the cycle. So they want to have lots of like specialized applications can do certain things and do it really, really well. So that's a similar trend. So in this world, right, what's going to happen is, I think all those specialized infrastructure and all those microservices, they all need data. They all need to be fed of what's coming and what's changing in the world. And then a lot of those systems are moving towards more real time, which means they want to be able to tap into those information as soon as they occur. So in this world, right, so you really need a system that can help move the data along. And you want the ability to feed all those downstream infrastructure systems, and you want the ability to feed those specialized microservices in real time. So that's the value we see in this data in motion system. I think it offers ability to essentially move the data around to all the places there you need to feed into. So the more of those specialized systems you have, the more valuable that system is. And if you look at it, it looks simple, but to do it really, really well is actually requires a lot of work, because you need to be able to deal with data at scale. Potentially, this is actually the platform where all the data within a company needs to flow through. Right? So you need to deal with all the scalability, durability, and the reliability so that you can make a compelling system.
Right. Thank you. Ali, John, back to you. Can you elaborate a little more about your plans for horizontal scalability? Ali, Suyog?
Yeah. So as of with respect to horizontal scalability, what we noticed is that a lot of our customers had to build their own custom sharding solutions, because one Zelos or one Zeus ensemble was not enough to host them. So with Zelos, we want to actually take advantage of us using the Delos platform and build some of these building blocks within the platform. And some of them include the concept of splitting data and merging data. We want to provide a transparent sharding layer so that we can take care of the routing and build versioning. And the reason why we want to build it in the platform layer is so that all the different API offerings that are built on top of the platform can take benefit from it. And doing some customer research within Meta of our use case, we feel that this is a good starting point. And then eventually we want to get into designing distributed transactions within the platform. So that's a bit about how we want to evolve the system so that we can horizontally scale and sort of take away the pain points that our customers face today with respect to using our solutions.
All right, so I'm going to have another question for the two of you. Can you elaborate more on the Zelos performance versus Zookeeper and how they compared for different workloads?
So in general, thanks for the question. In general, we are seeing that Zelos is outperforming Zookeeper on pretty much all workloads we are running in production. As it turns out, the out-of-order execution that we discussed for request processor turned out to be a key optimization that enabled us to do this. And again, since we are using a ROCDB, we are supporting much larger data size compared to Zookeeper. So if you want to characterize workloads, then Zeros tends to do better on read-heavy workloads thanks to the out-of-order optimization, and also it does well on workloads which have smaller writes. This property is derived from a RockCB, which we use as our local storage. And these two seems to be sufficient for us to support all production workloads that are currently running in production for Zookeeper.
I'm gonna have a follow-up to that. Is there any scenario where you use Zookeeper or Celos? Or Celos is going to completely replace Zookeeper?
Yeah, thanks for the question. We plan to completely deprecate Zookeeper usage within Meta. So we have not found any workloads that we support on Zookeeper that cannot be supported by Zelos. And so the goal is to completely deprecate Zookeeper.
All right, so I have one more question. This one is back to Lou. The consistency tracing library covers all the state transitions on the cache host. What if the invalidation is never delivered or delivered to the wrong cache host?
Yeah, that's a good question. So the consistency tracing is per host, like local. So it runs locally with within the cache process. So that's how it manages to monitor or trace every single cache state transitions, and then so that can help us basically debug when the system misbehaves. And then, but when the invalidation never gets delivered, then basically we're missing that information. So how we handle this, which we actually have observed in the past, when the pub sub just dropped a message without notifying cache. So how we notify this is that we will basically have a miss of the log entry in the consistency tracing to see, like, basically we never log the existence of invalidation processing, and then and also if it gets delivered to a different host, because we trace the entire cache invalidation pipeline. So even though the consistency tracing library is embedded in the cache host, but we do have coverage across the entire pipeline. So when the initial write is initiated, all the way down to the cache processing and invalidate. So we do know that the e-write exists, so that we know that you just kind of got mishandled or misrouted the invalidation. And also, this actually helped us in the past identify a bug around the invalidation pipeline, which means it's actually not a bug in the cache host, but it's just like the invalidation got dropped, if that answers the question. But that's a good one. Thanks.
Yeah, it does. Okay, so with that, basically, we're finishing the Q&A session. Thanks a lot for the presenters today. I mean, Lou, June, Ali, and Suyog. Thanks a lot for your presentations. Thanks a lot for staying for the Q&A.
Thank you.